Hello, Chemistry 10HH students. This is Mrs. Altman. We are on video number 37, Gases, Part 3. Here are our objectives for today's video. Pause here. So sometimes you're going to see in questions that it says such and such is occurring at STP. And what that means is that you are at standard temperature and pressure. Standard temperature being 273.15 Kelvin, so that's 0 degrees Celsius, and standard pressure being 1 atm. Neither of these things are going to affect significant figures, but sometimes you'll see a problem and you'll think that it doesn't make sense because you need pressure or temperature. You'll think something's missing, and these are the missing temperatures and pressures. Pause here. So now we're going to discuss Dalton's law of partial pressures, the same Dalton from before. That symbol here is a sigma. All that means is that you add things together. If you haven't already seen it in math, you're going to see this at some point in time. So what that means is if you have two different gases in a container and one has a pressure of 5 atm and the other has a pressure of 7 atm, that means that the total pressure in the container is 12 atms. We can just add the pressures together. Pause here. The flip side of this, which is just another application of Dalton's law of partial pressures, is something called the mole fraction. So the ratio of the percentage of molecules in a sample is equal to the ratio of the pressure. So what that means is if I have a mixture that is 20% oxygen in the container, that means that 20% of the pressure is coming from oxygen. Pause here. All right, I will work through this with you. So the ideal gas law also applies here. So PV is still equal to nRT. So the partial pressure of helium is just going to be equal to nRT over V. And I round it to my lower number of sig figs. Then I do the same thing for argon. You're always going to have the same other factors, your same temperature, your same volume, because the assumption is that all of these things are in the same container. Right, so that's my answers to A. And then the total pressure in the container is just the sum of the individual components. Round it to the proper number of sig figs. Pause here. Okay, I'll walk through this one as well. So the mole fraction is just equal to the ratio of the pressure from the individual component over the total pressure. And if you know the number of moles, you can solve it that way too. But if you don't know it, you know pressure, then you can use that. They both have to be in the same unit. And I round to my lower number of sig figs. This is a unitless quantity. So the answer is just 0.43. What that means is that 43% of the gas molecules or atoms in this container are xenon, and then the rest is something else. We don't know what it is, but we know that it isn't xenon. Great, that's all for tonight. Thank you so much for watching, and have a great night.